We've talked about axial coding. We began by talking about open coding. Then we went on to axial. Now let's talk about the what I would usually call the final stage of constant comparative analysis, which is selective coding. Now, select coding is um, frankly fairly similar to axial coding, except it's just a more refined version of what you were doing in the previous stage. Another difference might be that at this point, we are doing more to engage with theory, not necessarily meta theory, but specific theories that might fit within a larger meta theoretical tradition. And we're not just, making the data more and more granular. We're also attempting to simplify things a little bit here too. So, you want to think about the larger process of constant comparative analysis as involving an incredible amount of fragmentation to begin with, and a ton of granularity, and then a bit of added dimension when we're talking about axial coding, and setting up relationships between categories. And then when we get into selective coding, what we're really trying to do is connect what we've developed so far with some theoretical explanations. In other words, if we think that there is a causal relationship between these categories, what's a theory that is an existing theory or a new theory that we could come up with that would explain the causal basis of that relationship, or that would explain the process oriented relationship between these variables, that would explain the context based generalization that might be going on in the framework that we're developing. So rather than connecting what we're doing with really broad meta-theoretical frameworks, now what we're trying to do is to connect the data with frameworks that are more mapping onto a specific theoretical framework, either one that you're developing in a completely new way, which is a bit more challenging to do when you're relatively new to this business of qualitative research or research in general, or when you're trying to, and I think this is what happens more often, when you're trying to connect the categories that you've developed with existing theory. Are you adding detail by an existing theory? You're adding detail to an existing theory by kind of extending the theory, adding some detail to it, or adding, elaboration to the theory, or are you saying that this theory is relevant in only these contextual conditions? Are you, in other words, attempting to revise the theory? Theories grow and change over time, and they should. If we're not, our job in the realm of theory is not just to keep using the same theoretical frameworks over and over, but to, in the process of doing data analysis and doing research in general, deductive, inductive, whatever, to refine and expand or even revise existing theory. And so those are the kinds of things that you're doing at this point in selective coding. You are adding further dimension to the data. You may be refining some of the dimension that you have developed as you continue to move through your data and you finish up going through all of your data. And now you have all these categories and they're connected with some dimension or elaboration, or there's kind of a structure to this emerging framework. Now you want to try to refine that structure. Are there categories that are adding detail in a way that's not necessarily adding quality to the explanatory dimensions of what you're doing, and so you want to combine some of these categories and make it a little bit simpler. So in some ways, you may be expanding granularity, you may be breaking categories down further, or you may be combining and eliminating categories. as you move through your data and you finish up coding everything, you begin to see that there are some categories that occurred with such a low level of frequency that it may not necessarily make sense to keep them in your framework. And so you may want to eliminate them or combine them. Maybe you've got 7 categories, and these 3 of the 7 could be combined into one, so that now you only have 4 or 5 categories. And so really the selective coding process is where you're doing more to refine by either expanding granularity or collapsing or reducing granularity. And you're also trying to refine your analysis by doing more iteration between existing theory and what's happening in your data, where you are, okay, I've identified this pattern. Now let me compare it to an existing theoretical framework. What's the same? What's different? Do my data suggest that there is some additional granularity that should be added to the theory itself? And if so, what can I do in the business of developing and refining my theoretical memos to really nail down whether that should be done or not? What value is added by adding this category to a process, by adding this dimension to a set of categories that were not dimensionalized before? Or maybe they should be dimensionalized in a different way. Maybe we need to elaborate on the theory a bit and say this theory tends to hold in these particular conditions, but not these other particular conditions. So there is an iterative process here of jumping back and forth between the categories that you have identified in your data and the categories that exist in previous theory, and trying to figure out what are the ways in which what I'm learning here is expanding existing theory, revising existing theory. Um, and that's really the point. So think about this third stage of selective coding as involving a kind of theoretical coding, where you're trying to figure out, okay, now that I've decided that these categories are related in this particular way, what's the theoretical framework that would explain why and how they should be related in that particular way? And is that an existing framework that just happens to explain what's happening in my data? Or does it only partially explain it? And so therefore, my data have implications for expanding or revising an existing theoretical framework. Those are the kinds of things that are going on in the selective coding process. I also wanted to conclude by just, kind of going over some basics of using Nvivo and even other manual coding software for which you can do constant comparative analysis. I wanted to talk about, just some of the main things to remember around the nuts and bolts of actually carrying out these 3 stages of constant comparative coding when you're using software to do so. As hopefully you are. You can certainly code data in a much more elaborate and consistent and rigorous way, in my opinion, by using computer-assisted qualitative data analysis software, like Nvivo, for example. You're doing a lot of sorting data into categories, and you're doing it manually. It is somewhat replicable, but this type of inductive data analysis is really difficult to replicate in a way that would really line up well with traditional notions of reliability and validity. So a common question that I get asked is, does it ever make sense to use multiple coders? And I would say that yes, at some point in the coding process, it may make sense to do that. You might want to be the 2 or 3 of you might want to be coding data separately as part of the open coding process, and maybe even as part of the axial coding process. And then you may want to meet and kind of refine, compare notes in terms of what codes you developed. You will probably find that you developed fairly similar codes. This person did it with more granularity over here, but less over there. This person did it with more granularity over there, but less over here. And so you're going to need to kind of develop a consensus about what makes the most sense in terms of this emerging framework. But you may eventually be able to refine and come up with an agreement about a set of codes, and do some version of intercoder reliability, or just simply be able to confirm that, although we did not, develop exactly the same 227 open codes, that there was, that by the time we got done with axial coding, we very clearly had a consensus. And there was only disagreement in this many, in with regard to this many categories, this many cases, that kind of thing. Another important thing to remember is, and this is part of why it's difficult to replicate this kind of analysis in a traditional deductive social scientific sense, is, what are you coding? You're coding symbols that people have used during an interview, or that you have observed them using during observation or participant observation, or you have observed them using in the documents that they generate in an organization or a team or something like that. These are symbols, and symbols are messy. They are perceptual. They are subjective. One thing that we know about symbols is they never perfectly represent the phenomena that we're trying to represent when we communicate and in attempt to use symbols and signs to express ourselves. And so, because you're talking about symbols, there's always this gap between the symbols that you have that represent something, whether they're the symbols in the text that you're analyzing as you do constant comparative analysis, or the symbols that are represented in your code labels and your code definitions and the emerging framework that you're developing. It's all very messy, perceptual, and subjective. And there's always a gap between that we just have to assume is always going to be there. We don't know the exact nature or extent of the gap, but there's always going to be a gap between what we develop and what we're attempting to represent, whether we are participants in a study or whether we are analysts analyzing data in a study. And that can be very frustrating because it is so messy and perceptual and subjective. But you know what else is messy and perceptual and subjective? Everyday life. And so that is just a thing that goes along with this process of doing social scientific research. It's a thing that goes along with the process of attempting to do inductive research that could potentially speak to the concerns and questions and issues in other types of social scientific research that might be deductive. Because it was derived qualitatively and developed inductively, there's just going to be a higher level of ambiguity. And that's just what goes on in the process. Remember that, just like any kind of data analysis, deductive, inductive, abductive, whatever, we're trying to come up with explanations that simplify our understanding of something. That's the point. But remember that in the larger process of constant comparative analysis, we shouldn't do too much simplification up front. We should be reluctant to jump to conclusions. When we do jump to conclusions by making inferences, we need to document the inferences that we make along the way through theoretical memos. And the larger pattern is that you want to fragment your data, you want to complexify it by adding dimension, and then through axial coding, and then through selective coding, you want to eventually refine and simplify that framework that you're developing. That's the larger thing that you're trying to do in constant comparative analysis. I'll just mention a few things that can come up when with this task of importing data into a data analysis software program like Nvivo. Most of them now can handle data in a range of formats. There's even some emerging technology that allow us to import video. into data. There's not a lot of consensus about how to code video, and that is something that is certainly in progress. But the point is, these programs can import spreadsheets, they can import text, they can even import photos and video. The focus of this set of videos is really about the coding of text. And when you're coding text, it involves not just a piece of software, but a human being, a human instrument who has eyes, eyes that get tired, brains that get tired, someone who's working with documents that may be formatted in a particular way that is more or less easy to handle. There's just, there's a certain amount of just basic hand-eye coordination that comes from scanning text and using a mouse to highlight text and to categorize it. And so you may need to be paying attention to and maybe even taking some notes on what works well for you and what does not work well for you. For example, most people import text into Nvivo with relatively wide margins. You may not necessarily want to import your interviews with 1-inch margins. You may want to put 1.5 or 2-inch margins on them, because this way your eyes are scanning back and forth at a more narrow range, which may reduce the amount of fatigue that you experience as you're reading data and coding it. For some people, a wider margin may make more sense. You got to figure out what works for you. The larger point, though, is this is tedious. It's tedious, cognitively taxing work. And frankly, it should probably be done in small chunks. I would never recommend staying up all night and coding data. I generally don't recommend coding data for 2 or 3 hours at a time. The more you get fatigued, the more you get worn out, the more tempted you are to sort of oversimplify your analysis so that you can get through the process more quickly. And in the short term, that may feel like a good idea, and that may feel like it makes sense in the short term. However, there's a pretty good likelihood that if you do too much, too fast, through a longer stretch of time, you may make some coding decisions and some combination and elimination decisions around categories that you could regret. So I generally recommend that you figure out what works for you in terms of what causes you more or less fatigue, and figure out what works for you in terms of, how long can I do this kind of thing and really be in a good sort of zone where I'm making good decisions versus making decisions that more reflect fatigue and feeling tired and frustrating. For me, that means I don't code data for more than 1 to 3 hours at a time, and I try to pay attention to how I'm feeling. And if I'm getting impatient and feeling really tempted to move too fast and to oversimplify things, that's a good sign that I need to stop and come back to this at another time when I've got fresh eyes, fresh brain, and so forth. So that means you need to be thinking about how you're going to work data analysis time into your schedule. If you realize that you can only do it for a certain amount of time, then that means you've got to plan on when am I going to squeeze in an hour of coding here, 2 hours of coding there, 3 hours of coding here, 2 hours of coding over there. Figure out what works for you and find a way to build it into your schedule. So you really got to think about, what works for you and play around with that. Some people really like to highlight things and then click. Some people like to highlight things and drag things into different categories or folders. Again, figure out what works for you, what stresses you out the least, what wears you out the least. Those are some good things to keep in mind. Also, think about organizing your data into cases. Do you want to organize your data around people as cases? Do you want to organize your data around places or subunits of an organization as cases? Do you want to organize your data episodically? I've done research where I had a large number of expanded field notes from ride-alongs with first responders. And the work of first responders is organized chronologically through emergency calls. And you can think about each emergency call as a case. And other kinds of research, people may think about presentations as a particular case, a particular customer service interaction as a case, a meeting or a series of meetings as a type of case. Um, just because you're organizing data around cases doesn't necessarily mean that you're being all that fine-grained. What really matters is what are the attributes, the codes that you're adding. That's where you really are adding granularity and dimension and potential analytic insight that can be derived from your analysis. But ultimately, remember that qualitative data analysis software is just allowing you to organize your data and to structure it and explore it and write memos about it in a way that is going to allow you to potentially extend or revise theory or come up with a more rigorous systematic description of something that's going on in a particular process or phenomenon. And the software just helps you do that. But there is no perfect way to do it. There is no formula. A lot of this depends on the type of research question you have, the nature of the context that you're studying. There is no way, there is no perfect formula that anybody can prescribe for you that will help you identify the difference between a right and a wrong way in every case to analyze data. All we can do is give you some insight and some principles to use. And ultimately, what matters is, can I explain how I analyze my data? Can I justify, rationalize the choices that I made when I inferred this from patterns that I was seeing in my data? The main point is, can I explain persuasively what was learned from these data? And constant comparative analysis is one, I think, particularly useful technique for doing so, especially if you're interested in avoiding taking this EDIC approach where you're constantly trying to jam squares into round holes and round things into square holes. And instead, what you're interested in doing is letting the data, to the extent that you can, speak for themselves by you identifying patterns in those data that can be documented, justified, and audited and explained in a way that is persuasive and compelling and credible. The last thing that I'll mention is coding stripes. One of the things that I've noticed is they can be a useful thing, for me at least, in the process of coding, where I'm going through a document and I can see that things that are this color are associated with this category, and this color, this other category. But so they can be initially helpful, but at some point in the process, your analysis should get so messy, should involve so many codes that are not mutually exclusive, that eventually your coding stripes will not be helpful to you. And that's not a bad sign. That's a good sign. That means that you're coding your data with enough nuance that you are accounting for the messiness that exists in real life. And later on, you can refine that messiness. But at some point, so the coding stripes may be helpful for you initially, then they may become unhelpful for you. And that's not a bad sign if they do. But as you simplify your structure and you refine your data structure through selective coding, you may eventually find that those coding stripes become easier to use as we have eliminated all these extra categories, we've combined categories. So you might see it as a good sign if the coding stripes are initially helpful, then become really distracting and unhelpful, and you can unclick them and make them disappear. And then they may eventually become helpful again. So that's just another pattern that I've noticed in coding data myself and working with students who are coding data for the first time as well. So that's my overview of constant comparative analysis.